Hi, how are you doing? Today I'm back with a new video on Mastercam Tips and Trick. What's the topic today? Okay, let's take a look on the screen. I have a park like this. You can see we will study on this park today, and I have a few slots on the park. I have marked it with different color. You can see I have one slot in the orange color and three slot in green color. So what is different? It's easy to see. And look at this slot, the orange one. You can see the top and the bottom of the slot, they are laid on horizontal surfaces. So this is the normal slot. We can see this every day on many park. Nothing special, okay? And I call this one a 2D slot. And beside that we have three other one here, and one here. I call them 3D slot. Yeah, 3D slot. That's what I call them. Whatever you call them. I just want to talk about this one. Okay. You can see it's different with this one. They have at least one top or bottom, or both top and bottom lay on a taper surface. That means the surface is not horizontal. You can see, for example, this one. Okay. And I have three different cases here. The first case, the top of the slot is on a horizontal surface, but the bottom is laid on a taper surface, like this one. You can see that. And the second one, here on the right, you can see the top is laid on a taper surface, but the bottom is flat, is laid on a horizontal surface. Yeah, that is the second case. And the third case, you can see this slot, we have both top and bottom lay on taper face. So I call three of these is 3D slot. Yeah, that's what I call. Okay, so what we have to talk. Okay, we can start with this one, the simplest is a 2D slot. You can see normally you want to rough this one. Many people will use the ramping motion with a flat end mill like this. Go by the ramp motion, ding ding ding, ping 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 ping, like this one. You can see we take a ramp motion from the top to the bottom. Okay. Yeah, that's very simple with this one, a 2D slot. But how about a 3D slot? I will copy this operation and I will select a new chain. For example, this one. Ping, ping, and I reselect the depth. Okay. Yeah, you can see the difference here. First the tool is to solve for this one, but that's not important. We can create a new tool longer. But you can see here, you can see that we have a lot of non-cutting, or sometimes you call it air cutting move here. That's a tool need not engage the material. Here you can see this area is a non-cutting move, so that's waste a lot of time. You see that? And yeah, many people will have trouble with this, and you can see we waste a lot of time for this. And if the park have more than one slot, maybe 10 or 100 slot. You can see we waste a lot of time on roughing this slot if we use this machining strategy that you see. If we use the RAM, a 2D RAM here, we lost a lot of time in this area where no material. Yeah, you can see. And the same with this one. Mm, mm, yeah, maybe 24. Yeah, we have the same issue like this. No problem on the top of the slot, but when you go the tool move to the taper surface, you can see we have a lot of non-cutting move. That's not good, right? And nobody wants it. Waste of time, not good. And same with this one. Copy another toolpath, reselect the chain, and change the depth. Sorry, I need to pick a point here. Okay. Do it again, and see, we waste on the top of the slot, also at the bottom. So we waste our time here and our time here. Waste a lot of time, and that's not a good cut, right? Some people will use 3D. Maybe you think about a 3D contour on this, but we can try see how it works. The 3D. Okay, instead of select this 2D chain, I will select this 3D one. Okay, let's see what we have. Thing. Yeah, because it's a 3D chain, so we only have 3D, no ramping for 3D contour. Yeah, Mastercam does not provide you the 3D ramping, only 3D. So we will use a lead in and lead out, and for 3D you can only use incremental. Okay, and you will use the depth cut, maybe one. So let's see what we have. See that? Yes, it's look better. No waste of time. Oh, we need to change the depth here a little bit. Maybe 24 is, I think is okay. Maybe 20. You can adjust the depth, but yeah. We have another problem here. We don't waste time anymore, but we have a problem here. You can see at the corner right here and right here is the tool. Our tool will not make a smooth motion. It plunged into the material. That's not good. Not good. And it's totally shit. See that? This is the lead in and lead out motion. We don't talk about this. You can see here on the corner, this corner, yeah, you can see the tool it plunged into the material. Very steep angle, and this not good for the tool. Our tool don't like it. Really don't like it. That's really shit. So the contour 3D is also not a good option. Yes, don't think about it. So yeah, I try to find some other good solution for this type of slot, and yeah, I think about using the 3D toolpath. Yeah, 3D surface toolpath. And after I make some trial, I found that we can use a few 3D toolpath here. Yeah, today's the surface. We only use the finishing, okay, because I just want to use the ram motion to cut this slot. No rough, no 3D roughing because it may take a lot of time. Yeah, I just want to make a ram motion with a big tool, so it's just do the contour like this, and it's remove the material. Okay, so I found that we can use the waterline, the finished contour, and the flow line for this slot. Yes, they are not good for every case. Maybe one toolpath is just suitable for one case here, but there is one toolpath that's very universal, and I think it can be used to apply to all cases of this. That's the Flowline toolpath. Yeah, I very I love this toolpath very much. Yeah, okay, so let's see what we can do with the Flowline here. Okay, before I use this, I want to show you a few things. I have some curve here. That's the profile of the slot. When we look from the top view, you can see we have 1, 2, and 3 curve here. We will use later, okay? And we will create more curve later. I will show you when we do it, okay? Now we try with the flow line here. Okay, we start with this slot horizontal at the bottom, on the top, and taper on the bottom. So now we select the surface. Mastercam will ask us to select the dry surfaces. I turn on the solid selection, press the shift button, click on this surface, and on tangent surface will be selected. The Flowline toolpath only work well on the surface that's tangent. Yeah, you can see these surfaces are tangents, so it can work well on the flow line. Okay, then we click on the flow line button here to see the direction of the tool. Is maybe the use, and we have two direction in flow line, the U and the V direction. We can click on the cut direction here to change the direction we want. Okay, we change the step direction to cut from the top to bottom. Okay, and we select the tool where I have a 6mm tool here. This slot is 8mm wide, so I can use a 6mm and do a ram motion. Because this is a roughing operation, so I leave 0.1mm on the surface. And the finish flow line parameter, you can use the step over this either the depth of cut, and it's very important. You can see here we have the cutting method because we have no space for the tool to engage here, so the only way is, I think that the best way we can use is the spiral. That makes a motion like a ramping. Yeah, okay, try what we have. Ding. Oh, sorry, select the wrong tool plane. It should be top, not front. Okay, okay, because we machine from the top direction. Alright, let's see what we have. Ooh, yes, you can see it's look pretty nice. We can take a look from the right. I can increase the step over a little bit so you can see how the ram goes. Okay, you can see this is the ram motion. And when the tool go to the bottom, you can see there is no air cutting here. Okay, let's see what we have. Yeah, you can see on the bottom, but they're still not good because the tool is plunged into the surface right here, and we have retract motion. That's not good. So we go to the gap setting in the surface finish flow line, and we change the gap size. We use a bigger value, for example I use 25, so we can reduce the retract motion. Okay, try it again. So you can see we have no retract and the tool ran from the top to the bottom. It's very nice. Oh, there's still a ramp motion here. Oh, sorry, there's still a retract motion here. You can see the tool retract here and go plug here. So we have one retract. I will try to increase the step, the gap size a little bit, so we see any different. Yes, now we can see no retract motion. We only have ramp, but from here to here it's not so smooth, right? So try another way. We have here, so we can change to smooth to see if we got a better transition. Yes, when we choose smooth, you can see at the end of the tool path here of X level. Yes, you can see on the end of X level we have a smooth transition. Yeah, this look pretty good, but you will not satisfy with this one. This is really shit. Oh, let's find some way to solve it. It's not good. It's also a rare motion, but it's not good. So yes, I know it. And the second one, we need another trick. So we are not so successful with this one. It's pretty better. It's pretty much better, but still not perfect, right? Because we have some bad transition here. You can see it's not good. We don't want it. Yeah, that's maybe something about the surface. I really don't know about it, but we can try another way. Instead of select the solid surface, we will try to make the surface, not the solid, solid. Okay. So I will create another surface. I draw a line here. You can see. Yeah, you can. I draw a straight line here, a vertical line here, and I'm gonna make a sweep surface. Bing. This is the sweep contour, and then I select this line for shit, sorry, sweep, select the across contour, okay, and then select the along contours in only one, okay, because I select the two rail option here, so you need to make another one. If you use the other option, you don't need to make you don't need to select the two chain for the rail. Okay. Okay, so we have two line now, you can see that. And we go to the sweep again, select the across contour, and then we define the along contour one thing, and the second press this and second one, because I select two rail option here, so Mastercam require me to select two chain. If you select translate, you only need to select one chain for the along contour. Okay, so you can see I have created a surface like this. There's one very important thing is the flow line. That's the way you create a surface that will affect the direction of the flow line. So it's very important the way you create this surface. If you use a extrude or if you use a sweep, yeah, it can be different. So in this case, I use sweep for this operation. Alright, I may not use this curve. So I got this surface. You can see instead of we have 1, 2, 3, and 4 surfaces. Now we only have one continuous surface. You can see the difference. Only one surface, not 4 surfaces. Okay, and then I need to trim this surface. You can go to the trim here and select trim to plane. You click on the surface, click on end selection, and then you can select here entity, and we select this surface for the chain for the plane for split the surface. And don't forget to check on this split model so you don't remove any surface. Okay, you can see now our surface is split into two different surfaces, so we don't use this one and we can delete it. Click on this and delete. So now we have one continuous surface like this. It's very nice. You can see this is direction of the surface. You can see we have vertical direction and horizontal direction because we create by the sweep motion. I'm gonna show you if you create it using another. I will show you ting 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 ting. Okay, I will show you if you create by another way. You can see the the direction of the surface is different. So I'm not use sweep, but I use loft, one here and one here. You can see the direction of the surface is changed. It's not the similar one. Here we have this direction and this direction. So we will work on the sweep surface we create before. Okay, because this will be the direction of the tool when we make a cut. You can go direction vertical or horizontal. Okay, then alright, we go back to the our toolpath, and we select the surface again. We remove the old surfaces. This is the solid face and it's not work so well, so we remove it and we select a new surface. You will select the surface here. For more convenient, I can select on the mask here and I select this surface. Okay, so you can see now we only have one surface, and we click on the flow line button here. We can change the direction of the cut. click on the step direction here. So the tool now move in this direction and move from top to the bottom. This is this direction is clamp milling. If you want to go conventional milling, you can click on the start button here, and the tool will move with the reverse direction. So now we have conventional milling, but I prefer clamp milling, so I click on the start again, clamp milling, and cut from top to the bottom. Okay, you can see the direction of the surface. It makes the direction of the tool. Okay, now let's see we have any different. You see, I think we have some shit here. Still shit like this. Wow, that's crazy. You see, uh, you can see that the tool is not cut here on the right side of the slot, and it's much crazy. So you know what? After a few trying and making mistake, I have some experience. I think that can help you to avoid uh, problem issue like this. Yes, if you are not working right with the sweep surface, you will never get a good toolpath. Okay, so the last time we create this sweep surface by using this uh, chain for the cross contour and this chain for the along contour. And one thing I will show the surface for you, so you can see we have a start point of the surface is always start here, and I found that these are the position that's the issue normally happen here at the corner. This position, this and this normally cause the problem. So we don't want the sweep surface start from here. The first thing, we need to move the along contour, stay away from the across contour. You can move it anywhere you want, just move the along contour far away. Okay, and now I delete this surface. Another thing, we don't want the across chain start at this position, this position, this or this. My experience is you break this curve here at the center of the arc here like this. You go to the wireframe, trim and break two pieces, select this arc, and you break at the center. Okay, and I think it's better if you break it at this end. Okay, like this, break two pieces, check, and select the midpoint for breaking. Break two pieces and select the midpoint. So you can see now the arc is break into two segments. And now when we do the sweep surface, we can select the cross contour start from here at the middle of the arc. Right? You can see the chain now start from here, not here, 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 or here. This is dangerous position, I think. Just my opinion. I'm not sure, but it's worked for me. So you can try to break the arc at the center point, and then we select the along contour again. Now you can see the sweep surface. It has a line here that is the start point of the surface. Yes. And now we trim this again. Ping, ping. Select this surface. Ping, ping. and delete this. Okay, now we can select the surface again. Ding, and the flow line you can see. Now you can see the flow start from here. It's not start from this corner, this corner, this corner, or this corner. Just right on the center of the arc. I think this much better for toolpath creating. Okay, now see what we get in. You see that? Wow, it's beautiful. You see? Take a look from the left side. You can see the toolpath is much better. I will change the holder a little bit longer. Okay, maybe 26. Yeah, okay. Now we have a closer look on the toolpath. You can see the ram motion. In, very smooth. And we have a ram motion. In. Yeah. That's so amazing. You can see when we choose the smooth transition, you can see there's a smooth transition here. And when you, if you want to direct, you can go here, and you got the direct transition at the bottom. It also a ram motion. You can see there's a ram motion. So we can eliminate the waste move of the tool where it's not contact with the material. So for safety or clear, you can extend this surface a little bit. Extend here to the bottom, or you can extend it from here to the top. Yes, so there's one important thing you need to remember, that you should break the chain at the center of the arc. Do not start from here, or here. It's very dangerous and it make the toolpath go crazy. That's my experience. And you move the along contour far away from the across contour. Do not go like this. So you don't want to push it the sec here, because when you make it here, you cannot it's difficult to select the start point of the cross contour like this. I will show you sweep. When you select this, you can see the start point automatically move to this point. This is a dangerous point we don't want. Okay, so it's best you move this to another point anywhere you want, but don't touch the cross contour here. Okay, so when we go with spiral and the flow line, we have a ram motion for this slot. Very nice, right? And I will input a large value so you can see the ram motion. Yes, you can see that. This is the ram motion. And no air cutting here, this area. Yes, you can see how much the Flowline Toolpath can do. We have many video on the Flowline Toolpath, and it can do a lot of things. Amazing. Okay, so we move to the next. This one, okay. We will do the same. I will try to make a. Oh, sorry. I will try to make a sweep surface. Okay. Whoa. Now I will try it again to see if we got a good toolpath. If we start from this point, this is a dangerous point. You can see the corner here, and here is the dangerous point. You should avoid it. Okay, to sweep. select, so you can see it's automatically start from this. Bing, bing. Okay, now I try to trim it. Trim to plane, click on the surface, and then select entity, click on this surface to trim. Okay, oh, there's something wrong. Maybe we should move this chain a little bit up. It's close to here. We should move it a little bit up. Okay, like this. Alright, do it again. Sweep, ping, select across, and then the along contour. Okay, and we trim this surface. Ping, 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 ping. Okay, and then we delete. So now we have a surface like this. Now we trim it at the bottom. Tang, tang, tang. Trim, trim to plane. Select the surface, and then entity. Select the bottom face. Ping. Okay, so now we delete. Yeah, so you can see we have a trim surface, right, like this one, and we try to create another Flowline Toolpath. Remove the old surface, select this new one. Okay, need to click offset to move it inside, click on start to change the direction. Okay, pew, let's see what we got. Yes, this look nice, right? Yes, but there's still problem here. You can see it's look nice, but we still have a problem here. There is no step in this area, and we have a shortcut here, so this is not just perfect. Yes, you can see the problem here, right on the dangerous point when the line contact with the arc. So you can see this is the dangerous point, and it's not give us a good tool path. So you can change to a gap here and select smooth. So you can have a smooth transition here. You can see we eliminate the air cutting outside of the part, but have an issue here. Yeah, right on the dangerous point when the arc contact with the line here. So we use our trick again to see if it work or not. We delete the old surface here. Oh, remove it. Okay, we move this chain away, maybe to the center, or maybe far away from this, and we break this point. We break this one. Ta-da, ta-da! Wireframe, break two pieces. Click on the arc and break at the center. Okay, and now we create the sweep again. Ding. Select the along contour. Bing. Yeah. You can see we have a start point here, and then we trimmed it. Pew. Trim to plane. Click on the surface. Pew. Trim. Pew. Okay. Delete this one first, and then we trim it again. Trim. Pew. Select the surface. Enter, and then select entity. Pew. And when click on the bottom surface. Pew. And then we remove this bottom. Okay. So we have another sweep surface, but you can see now the start point is start from here, right on the center. This will be better, I think so. We select the right again. Choo! Flow line, offset, and start. Alright. Let's see if we get better. Oh, we still have this. So the solution is sorry. We can sorry. We can break the chain here, not here, but here. Okay. We can join this. Two joints. Okay, we break this one, not this one. Ooh, break two pieces. Ding, ding. Okay, do it again. Sweep. Shoo. And we do it fast to see if it work or not. Alright. Now we trim this. Shoo. Shoo. One. Two. Okay. I hope I'm lucky this time. Two. Alright. Select the surface again. Ding, 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 ding. Oh, I hope I'm lucky today. Choo, choo. Let's see what we have. You see that? It's perfect now. Amazing, right? You see that? It's beautiful. So amazing. It's smooth and no gap. We have no waste cutting here. Yeah, the tool is too sharp, but there's a little bit of it's not smooth here at the top of the slot. You can change this by we give it a little bit of cut tolerance here. Okay, we still have, yeah, we can increase this a little bit because this is a roughing operation, so the tolerance is not so important. So you can see we have a smooth tool pad now, and I just change the tool for this tool pad, so we get a long enough tool. Okay, it's look nice now. I reduce the step a little bit, maybe 0.5 or millimeter for one depth of cut. Okay, and it's work like a champ, right? Shoo shoo shoo. Very nice. Okay, so we have two slot, and now we go for the final. So I will break the chain first before I create the sweep surface. Break two pieces. Pew pew. Okay, we move this a little bit up so we can trim it properly. Okay, and we draw a line. You can draw at the center. Yeah, just avoid the dangerous point. This point, this point, this and this. Avoid this. You don't want the cross contour start from this position. Okay, we do the sweep, sweep, shoo. So you can see it start from here, not at dangerous point. Shoo. And okay, and then we trim it in, and then entity. Shoo. Okay, we trim the upper side. Now we trim the lower side. Trim to plane, select the surface, and then click the entity you use for trimming. Choo, choo. Okay, we copy another tool pad, use the 6mm tool, and select a new surface. Choo, choo, choo. It look good. but I'm not sure if it run good. Let's try. Yes, it's beautiful. You can see that it's very beautiful. Wow. So we don't want to this, so you can see we have the toolpath slot roughing toolpath here, here, and here. Very beautiful. You can extend the surface a little bit so the tool will start from outside of the material. It's a safe way to do the roughing. I just want to demonstrate here. We don't use this anymore. Okay. Remove them. Okay. That's the Flowline Toolpath, and I'm gonna show you the high speed, uh, dynamic contour. Dynamic waterline. See how it works. If you use the dynamic waterline, yes, tool, this one, yes, transition, ram. Because in this video I don't want to talk so much about the waterline because it's not the ultimate solution for all of these 3D slots. And then the waterline does not provide us the ram motion. You can see we need to change the stew inside. Okay. So this is the waterline. You can see it's different with the flow line we use it. It's look good, but it's not fully RAM. You can see this is a 2D, not a RAM, just RAM for transition from this level to the next level. But it do like this. You can see this is not a RAM motion. So you can see for this type of 3D pocket, you can use the waterline toolpath also. But I think you cannot use for this one. We will try to use a waterline for this one. Okay, and the containment. Choo. Oh, we need a smaller tool, 6mm. Okay. Choo. You can see the waterline can trim the non-cutting at the top, but in the bottom it cannot do it. So the waterline is not good in this case, in this situation, because it cannot trim the toolpath here below the part. It only can trim the excess toolpath here. So that's good, not good. Like the flow line, you can see the flow line here, it trim the top and the bottom, but for the waterline it's only trim at the top of the slot, so that's not so good, right? Also for the type of pocket slot, we use a waterline. Okay, and the containment here, we have the same result. Oh, this look crazy. You can see that the waterline cannot trim the bottom of the slot, and also we don't have a fully ram motion. We just only have ram motion for transition between this level and this level. You can see they are 2D level with this ram transition, but for the flow line you get a full ramping. You can see it's a full ramping, so that's why I prefer to use the flow line. It can work very well on trees case. You can see that very effective. And for the waterline, it's not so good, right? It can work pretty nice on this case, but for this slot and this type of slot, it's, it doesn't work well. So I recommend the flow line for any kind of 3D pocket. Sorry, 3D slot. All right. Yes, that's a lot for today. Woo. I love the flow line so much. You can see, very nice. Okay, I think that's enough for today. Oh, this is a very long video. Okay, I think I can share something interesting to you today, and I will keep playing with Mastercam and try to making some try to make some new interesting video. Okay, thanks for watching. Goodbye for now. See you later. Okay.